Hey guys, welcome back to Consistent Code. So today's problem of the day is minimum exchange. Now, there's one thing I need to tell you that in this problem statement is not exactly correct. So let me explain you what the problem actually is. Suppose the matrix is this. Let me take this one. This is the output, but I will reframe this in the form of question. Say this is the case. So what was the question? A, and then B, and then B. So basically what the question is asking is that you need to count the minimum number of operations you need to interchange the character. You can either interchange this A into B or B into A, so that every adjacent element of every element is different. For example, here we have A, then its top, its left, its right, and its bottom should be B. So if you observe carefully, then there are only two possibilities to achieve this. One of them is this one, which is given here. Let me just put it. Wait, let me just. Okay, let me just try it. So one possibility is this, and another possibility could be, this one, that you can have B A, then A B, and then B A. So what can you observe from this thing? That for any given matrix, there can be only two possibilities. Either you can start with A and fill it like A B, then B A, and so on. Or you can start with B and fill it like this. So these are the only two possibilities which you can have. Now you need to determine that if you convert this given matrix into this matrix or this matrix, then the one out of these two matrices in which you can convert it, you need to find the one where you need minimum number of operations to convert the original matrix. So let me mark this also, that this is the original matrix, this is your result 1, and this is your result 2. So you need to find the minimum number of operations in which you can convert it into either result 1 or result 2. So that's what the question actually is, and the problem statement is actually ambiguous for this problem. So for this case, we can actually check by converting this original matrix into both of these matrices and count how many interchanges we made. So if we convert it into the first result, let's count those number of interchanges as count 1, initializing count 1 as 0. And if we want to convert this matrix into this result 2, or the second way, when we are considering B as the starting, then let's say that for those the number of interchanges are count 2, and let's initialize count 2 as 0. So what we can observe now, that the indexes, we can just find the value here. Suppose I want count 1. So first of all, we need to iterate over the original matrix, obviously. So let's write the code for that. So this will iterate over all the rows, and this loop will help us in iterating over all the columns in that ith row. Now what we need to do in over every element, so we need to check something like that if you see, suppose consider this element, the first element, then you can see the index of the column and the row, it's 0 and 0. So what does that mean? That you can use the row and the column's index to determine whether it should be A or it should be B. So let's say if I plus j is odd, then, and let's consider one more thing, that if this matrix ij is A, I'm considering it like this, then I can have that if I plus j is, for example, just consider this first case. In this I plus j, here 0 plus 0 will be 0, hence, and consider this index, that will be 2 plus 0, this is again even. Consider this index, this is 0 comma 2, again even. So a's are at all those places where I plus j is even, and in this you can observe that d is at all those places where I plus j is even. So if I want now, so that my I plus j is even, and this is the count 1 case, so I need to replace, if it is an A, only if so first of all, if it is even or odd, I need to decide that. So in this if condition, if I plus j mod 2, that means if this is odd and I am having A at that place, then I need to replace here in this result 2. So here I can just say that count 2 should be incremented, and otherwise I can say that we need to increment count 1. Why? Because if I plus j is even and we are having A, then we need to change that into sorry, we have done a mistake here. So if the element is A, and then we are checking that if I plus j mod 2, that is if I plus j is odd. So if it is A here and I plus j is odd, that should be in the case of B, then we are replacing it in the case of result 1, so that actually needs to be count 1. And if I plus j is even, then that should be B should be in the case of even places at result 2. So in the case of result 2, if we find in the original matrix where it should be B occurs A in the original matrix, then we should replace it. So here we should increment count 2. I hope you understood that if we are having A, then we are checking that if I plus j is odd. In the case, so this is the case when it is odd, and this is the case when I plus j is even. So if matrix ij is A and I plus j is odd, then what we are doing, if I plus j is odd, because this is the original matrix, so if we want to convert this into first type result, then we will be incrementing in count 1. Now when we need to increment this count 1, only when we find, because in count 1 at odd indexes there should be B, so if we find that it is an A here at the place of B. Like here, we find that at I plus j is odd and we count A, then we should increment count 1. And for in other case, like in if we want to, if we have A here, then we can increment this count 2, considering if you want to convert in result 2. So here we have incremented count 2. Now there is another case when we are trying to convert this I mean that when the matrix I is B, suppose this is the position, this is B. Now we need to check again the same thing, that if I plus j is odd, now what we need to do? In this case, since it is a B, and here we, if we check 0, 1, 2 and 0, so this one is even, and we want a place where it is odd. So suppose this place, here it is odd. So if I check result 2, in result 2 at this place it should be A. So I should increment count 2 in this case, and for the other case we should do the vice versa, like we should increment count of 1. Understood? So that's it, and then we need to return the minimum count. That's all the question is asking us. What are these count 1 and count 2? These are basically storing the values. If we convert the original matrix into result 1, then how much minimum operation we require, then that is count 1. And if we convert it into result 2, then count 2 is the number of operations which we are going to require. So we need minimum number of operations because both of these are valid answers. So we will take the minimum of these two, and that should be it. Let's try compiling and running this code. So we see that it's working, and let's try submitting the code. So we have solved the problem successfully, and I hope you liked the explanation. You can drop any comment if you did not understand anything, and you can subscribe and like this video because you can find the content like this every day. So I will be seeing you tomorrow with the next problem of the day. So bye bye.